In this unit, we're going to learn about user-defined functions, how to create them, how to use them. Let's start with the purpose for user-defined functions. These allow you to complete a task without rewriting code. If you're only going to do a task once, well then you'll write a script to complete that task and be done with it. But many of the tasks that we complete when we're working with R are tasks that we're going to need to take on again. So by writing a function, we don't have to rewrite the code each time. This actually helps make our code more readable. When you're looking at a script, if you have in fact a task encapsulated within a function rather than having to look at the whole script again, it makes that particular section of script that contains that function more readable than if you had a script within a script. And this makes scripts shorter. You could think of a short script with 10 functions as really representing 10 different scripts. This also makes it easier to fix bugs when there are problems, when something happens that is not the way you expect it. You can isolate which function is causing the problem and in turn be able to narrow it down to the script that's behind that function. And it makes collaboration and sharing easier. When you write a function, you can give it to someone else to use and vice versa. So you don't have to keep reinventing the wheel if someone else has already invented it. You can use their wheel. Let's look at the components of a function. We need a name, arguments, body, and a return value. So here's an example of a function. Now my first few examples are rather silly. I'll get into some more practical examples later. But it's hard to think of a practical example that only takes 1 or 2 lines of code. And to learn the function, it's easier to do so with 1 or 2 lines. So just bear with me for now as I show you some silly little functions just to show you how to create these functions. This function squares a number and adds 5. So note that we have an object name square plus 5. Just like when you create an object and assign data to it, you create an object and assign a function to it. You do that with the function word, function. So we're going to assign a function to square plus 5. And then you have arguments for that function. In this case, we just have 1 argument. Now this argument is a formal argument, not an actual argument. The actual arguments are going to be sent to this when someone calls the function. Right now it's a formal argument, and that formal argument actually plays an important part within the script. This X is the placeholder for whatever anyone will send to the function, but we use the X in the script to show what we want to be doing with whatever someone sends to that function. So if someone sends a 5, we want to square it. So here we have x squared for 5 squared. If someone sends a 7, we want to square it. X squared for 7 squared. So we have the name of the function, square plus 5, the argument. Now the body of the function is this whole part here in which we actually carry out the activities that we want to carry out within the function. This, we want to square whatever is sent to the function and add 5, so that's what this part of the script does. That's the body. Notice that I store this in R result, and then notice this command here, this function, return R result. This will be what our function returns. So this will actually be sent to square plus 5 after all the work is done within the body of the function. So when I click on this, in order to run this little piece of code, if I look in the environment, notice we now have in the environment the square plus 5, and it states that it's a function with an argument x. So this function now is in our environment. If I click on it, we actually see the function isolated by itself right here. Okay, so back to running the function. Now that our function's been defined, let's try calling it. So we call it the same way we call any kind of function, with the name of the function, and then we have to have one value sent to the one argument. So here it is, square plus 5, and we get out, as a result, 54 because we sent a 7. 7 squared is 49 plus 5 is 54. So that's how we create a function, just that simply. We create it with a name, the function keyword, the arguments, and then curly braces, opening and closing, within which is our body and our return. Now note that this function is already vectorized. Watch what happens when I set my vector equal to 3, 7, 11, 21, and then send my vector to square plus 5. R is a vector language, and so when we provided the argument of x way back up here on line 31, x is assumed to be a vector. It can be a single number, which is a scalar, which is a vector of length 1, or it can be a vector of length 4, like we've done here, or any length. And then every single item is squared and 5 is added. Now I believe that an explicit return function, such as what I showed you in our first function, that is, when I looked at this function here, I showed you that I have return our results. That's explicit. And I think that helps the readability of code. So I would recommend you use it. But it is not necessary. If there is no return function, R will return the last element that is evaluated in the function. So here is the same function again, but with no return. So what will R return? The last thing that happens is on line 54, x squared plus 5. So whatever that equals, that's what will be returned. So this is really going to accomplish the same purpose. So let me, again, have x squared plus 5, but this time if you look at it, you'll see it has no return function to it. And so if I run square plus 5, then it's going to give me the 54 again if I send 7 squared plus 5. So it serves the same purpose, and it might look to you like this is the better way to do it because it's shorter. But I just believe that the return, making it more explicit, makes it more readable. But it's primarily a matter of preference and what you can understand when you look at the function, whether or not you need that return in there. Now let's make another function that's a little more general. For this one, we send it a vector, and we're going to tell it how much to add. So rather than just squaring and adding 5, I'm going to square it and add it something else. And that something else is going to be in our second argument. So now instead of square plus 5, I'm going to call this square plus. You see here in our environment, square plus is in there. So now I have two arguments, an x and a y. The result is going to be x squared plus whatever y is, and this will return our result. So let's run it. So I'm going to send that vector again, the same my vector, 3, 7, 11, and 21, but I'm going to put as the second argument 15. So we'll get 3 squared plus 15, 7 squared plus 15, and so on. And here it is. 24 is 3 squared plus 15. 3 squared is 9 plus 15 is 24. 7 squared is 49, plus 15 is 64, and so on. Now, what if we only sent one value to our new function? Remember that when we defined the function back up here on line 62 through 67, we gave it 2 arguments. So what if I only send my vector? Let's try it. Let's type this in. We get an error message. Argument y is missing with no default. As the error message states, we're missing an argument that does not have a default, so let's set one up so that therefore if no second argument is included, it will still run. So I'm going to set a default this way. I'm setting y equals to 0. And now, if I don't put in a y, 0 will be used for y, meaning that it will square without adding something. So now let's put in our new function. Let's call it again just the way we did before with only my vector with nothing for y. And we see it works. It just squares the numbers. On the other hand, if I put in something for y, it overrides the 0 that's there for y. And we end up getting now the value squared plus 15 because I sent 15 as my second argument. Now what about the other direction? What about instead of not enough arguments, we give it too many arguments? Let's try typing this next one in. Notice here, I'm giving it 3 arguments, even though I'm only calling for 2. Well, it's telling us unused argument. It's giving us an error message again. That's a problem. Now, if there's a reason that we're going to need sometimes to have a third argument, like when we pass through additional arguments, as I've mentioned to you in the past, and I'll show you again later, then what we can do is use the 3 dots. So notice my function now, x, y equals 0. So there's an argument, the x argument has no default, so it's necessary, it's required. Y is not required, it's optional because we're giving it a 0 as a default. And then the 3 dots allow for additional arguments. So here's the function. I'm going to redefine it here in my functions. And now we'll put in my vector 15 and 45. And it works. The 45 does nothing. It's totally ignored. So let me remind you again why we sometimes include the 3 dots. We do this if there's any chance that inside our function we might want to do something with another function. So let's look at an example. Here's a function that's going to create a scatter plot and return the correlation. Let's include the 3 dots. So notice that all I'm doing here is plotting and calculating the correlation of x and y. X and y are both required. There's no way to do this without them. And so there's no default that I'm setting here. Let me go ahead and define that function. So CorePlot is now one of the functions available to us. Let's create 2 vectors, explanatory variable and a response variable. And now let's run CorePlot for those. Okay, when I run CorePlot, what I get down here is the correlation, 0.73, and a little plot to show the relationship of x and y. Okay, no big deal. It's something we could have done separately without having that particular function. But now suppose I decide to send some additional arguments for the plot. Notice that when I defined CorePlot, again, I only needed x and y, but I put in 3 dots just in case I might want to pass something additionally through. So look what I'm doing now. I'm not only putting in explanatory variable and response variable, but I'm putting in a label for x, a label for y, and a color. So now when I run this, I get a label for X, a label for Y, and I get the red color. In other words, my function did not have any of those things in here, but the 3 dots allowed me to pass it through my core plot function to the plot function, so that when the plot function was called within my core plot function, these 3 extra arguments were used and became useful.